Okay, you guys, so what we're going to do here is we're going to do a little review of graphing. I'm going to take advantage of what we call transformations, and I'm going to be doing it without a calculator. Being able to observe or see a graph without the technology is going to be a pretty good skill to have, and hopefully it'll be a good review. But before we start anything, let's just first of all make sure we understand what a solution point is. Okay, and what a solution point basically is, right, it's a point that basically satisfies the function. Right, it's an input-output system that's in there. So, for example, we could plot these, any one of these, by creating what is famously known as a table of values. And the idea is, like, if I was to let x equal to 0, if I plug that in here, I get 3/4 0 minus 6. That's 0 minus 6, which is -6. So this 0, -6, not only is it the y-intercept that we know about, right, but it also is a solution point. And basically what a graph is it's a consideration of all the solution points. So every x creates this y kind of situation. And so rather than doing this over and over and over again, let's just take advantage of some things that we hopefully learned in our college algebra class, take advantage of some transformations, and go from there. So in this case, we know this to be a line. And it's in the good old y equals mx plus b form. And so the y-intercept we've already found is at 0, -6, and the slope is at 3/4. So to find another solution point, right, I would go from the one that I have, 0, -6, and I can basically, right, go up 3 and over 4, and another solution point would be 4, -3. Now again, the idea is if I would let x equal to 4, right, notice the 4's will cancel out. 3 take away 6 is -3. So again, that's the idea of being a solution point. You satisfy the given equation. So we found 2. I usually like at least 3 points on a graph to make sure you've got a lot of the major details. It might take more. So to get another point, in this case, we just keep going in the direction of the slope. So up 3 and then over 4. So it looks like the point 8, 0 is also a solution point. And of course we plug that in there. 4 goes into 8 twice. 3 times 2 is 6. Take away 6 gives us an output of 0. So we have 3 solution points, and we connect the dots, and what we're looking at, right, every point along this line satisfies that equation. It makes it true. It's a solution point. So that's what graphing is all about. It's about finding those ordered pairs that make things work. In the next one, I'm going to make use of some transformations. When we look at this, the basic function is my x squared function. And what we're doing with the x values, we're adding 2. Right? This causes a shift left 2 units, and this plus 5 means we're going up 5. So my normal x squared graph, right, that kind of looks like this at 0, 0. What it's basically doing is it's moving 2 over to the left, and 1, 2, 3, 4, 5 up. And then I think we have -1, 1, and +1, 1. So those points will move right along with it. So there are 3 points on this graph. It looks like I have what? -2, 5, -1, 6, and it looks like -3, 6, right, as points on that graph. Of course, you could verify that by plugging that in, right? -1 plus 2 is 1. 1 squared is 1 plus 5 gives us 6. -3 plus 2 is -1. Squaring it, we get 1 plus 5 gives us 6. So again, they are still solution points, but I was able to graph really fast by looking at the basic function and then transforming it the way it needs to be transformed. So again, a very nice graphical trick in terms of graphing if you remember your transformations and basic shapes. So in the next one, it gets kind of straightened up here. Don't know what's going on. There we go. All right. When I look at this graph, the basic function is the square root function. Again, that starts at 0, 0, and it essentially has that shape, right? 1, 1's on the graph, and I guess 4, 2's on the graph, right? If you're looking for some data points. What's happening to this guy? Well, the x isn't being impacted, so there's no shifting left or right. The negation out here is happening to the function itself, so we have a reflection through the x-axis, and then we're shifting up 2, right? So up 2 units. So this graph starts off by initially being shifted, right, reflected through the x-axis, right? So there's negative square root of x, and then this graph gets shifted up 2 units. So every data point is basically going to shift up 2. And so here would be the graph of negative square root of x plus 2. It looks like it has, looks like it has 0, 2 on the graph. It looks like it has 1, 1 on the graph. And it looks like it has 4, 0 on the graph. And of course you could double check that pretty easily, right? If x is 0, we get 2. If x is 1, square root of 1 is 1, negative 1 plus 2 is 1. If we put a 4 in there, we get 2, negative 2 plus 2 is 0. So there's basically the graph giving me 3 solution points. I just basically manipulated solution points on the basic graph, reflected them, and then shifted them up like the information's telling me. All right, in the next graph, related to the last video we just did, right, we can see that we have a division by 0 problem, right? X cannot equal to 4, so that tells me what my vertical asymptote is. So I have a vertical asymptote at 4. All right, in terms of a horizontal asymptote, the dominating features, right, are x and x. So we have x over x, which is 1. So it has a horizontal asymptote at 1. So now I need to figure out, is the graph here, 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 or there? And that's where we can do some point plotting. How about we find a y-intercept first? If I look at f of 0, I get 0 plus 1 and 0 minus 4, which is negative 1/4. All right, so 0 and negative 1/4 would put us about right there. So this already tells me a couple things. As we move this way, the graph's supposed to get closer and closer to the horizontal asymptote. As we move this way, right, the graph gets closer and closer to the vertical asymptote. All right, and then of course now we have to figure out, am I here or am I here? And perhaps we just do some more point plotting. So how about we put a 5 in there? So f of 5 gives us 5 plus 1, 5 minus 4, which is 6 over 1. So 5, 6 is on the graph. So that means we have to follow that asymptote this way and eventually have to follow that asymptote that way. So there's basically how I would graph that rational function using some of the information we learned in the last video and without a calculator. Of course, you could use technology to verify it. So again, there's some quick sketches. It's all about finding solution points. Again, if you wanted to, you could literally find some solution points by plugging things in and getting enough of them. You can take advantage of transformations, or you can take advantage of kind of a lot of information, vertical asymptotes, horizontal asymptotes, y-intercepts, and even using some more data points, some solution points. All right, so hopefully that gets you started on your graphing. We're going to be graphing some pretty important functions pretty soon, and we'll be transforming them. So make sure you're comfortable with doing that.